So good day, I'm here to present my solution using Kohonen learning algorithm. And let's get started. So here we have input x and y. So we need to use linear self-organizing map with 5 times 5 neurons. So in each neurons, we have weight x and weight y. So the reason why it has weight x and weight y is because of the inputs. So in here, you can see that each neurons has corresponding inputs. Like if I have three inputs, I can say that I can have weight x, weight y, and weight z. But since there are two input, so we need weight x and weight y. So we need to initialize randomize weight for each neurons. Two weights to be exact, which is weight x and weight y. We need to set the learning rate to zero point 0.1. So we also set the Mexican hat radius or sigma to 5 and max epoch to 50. So first things first, we need to randomize selecting random values. So I can just select 50 or maybe 05 for my first input. But because if I choose another value, it would change completely or entirely the result of each uh, old weights, because as we advances to each different input, it will be dependent to the old weight. So if I choose negative 43, then 0, 5, 0, -5, the value of its initialized weights and old weights, the old weights will be different if I choose 0, 5, and 3, 4. So in here, we already have an input of negative 3 and negative 4. So first, we need to find its value of each neurons. What I mean is, we initialize first the weight of each neurons. But what will be the final value of each neuron so that we can find the minimum of the minimum value of its neurons. So I will show you how I arrive at this solution of finding this neuron value using random input. So here we have input 5 and 2. 5 for x and 2 for y. So in order for us to find its neuron value, we need to use Euclidean distance. So we need input x, which is 5, and the old weight x and the old weight y are considered to be initialized values of weight of each neurons, or maybe the updated values for each neuron's weight. So here we have negative 0.035 for the old weight x and negative 0.07 for the old weight y. So we need to minus 5 minus negative 0.035, and that would result to positive since we subtract it to negative. So 5 plus 0.035 plus 2 plus just like what we did earlier to 0.073, that would result to 5.035 squared plus 2.073 squared. Then we squared it to 25, and the result would be 25.35 plus 4.97 and 29. So the result would be 5.44 for this neuron, for this neuron. And then so it would result to this one. So we need to we need to use it again to solve each neuron, where after solving each neuron using Euclidean distance, we need to find its minimum. And after finding its minimum, we need to use its index. Why use its index? It's because in map, we can pinpoint where is that index of the lowest or the minimum value of the neuron in that given input. So after that, we need to update the initialized values. So in order for us to do that, we need to use this formula, which is old weight plus learning rate times exponential function raised to the power of negative best matching unit x minus new weight x, which is the index of the weight itself, then squared plus best matching unit y minus new weight y, or the new index for the y value, squared divided by 2 times Mexican hat squared times input x or y, since we need to uh, solve for each weight weight x or weight y minus the old weight. So our initial Mexican hat radius or sigma is equals to 5. Our max epoch or the training set would be 50, and learning rate is equals to zero point 0.1. So our old weight would be used is negative 0.035, and for the new value for this uh, initialized weight for x, so we need this to find this new x or new weight x also here. So our value is negative 0.035 plus zero point 0.1, which is learning rate, times the constant value of exponential function, which is 2.71, 82, 81, 82, 84, 59, 04, raised to the power of negative 3, which is our best matching unit here, the minus 0. So the index is 0. Index is 0, then 0. Uh, new weight x 0. Then best matching unit is 2 minus 0. So just what like I said, that 0, 0, then 0. Maybe if I want to find the new uh, weight for this cell or neuron, I need to use this value, new weight x, which is 2 and 2. Then times 5, which is our input, minus negative 0.035. We need to prioritize the exponent. The exponent. So 3 minus 0 squared is 9, plus 2 minus 0 squared is 4. So 9 plus 4 divided by 50 would become 13 divided by 50. Then when we divide it, negative 0.26. Then when we raise it to negative 2.718, the constant value of exponent, we will get 0.77105 times 5.035, which will result to 3.88 times zero point 0.1, which is 0.3882, plus negative 0.35, which is 0.353. So this will be just for the new value for the x. So what should we do for the value of y? So we need to change the value of x to y, which is negative 0.073. And the same with the method we use, uh, we can get the new weight for each neurons. So here, as you can see, when using the formula, the new weight x, here the new weight x would depend in the index. What I mean is x would be would be here 0, like 0. If I want to find this, my x would be 0. But if I want to find the value of this one, my x is 2. Just like y, if I want to find the value of this, my y is 3. We can now use it. We can now use this uh, new initialized values or updated values we so that we can solve for another neuron value. Here, after solving that, we will get this kind of values. So our new weight would become like this. So our weight x is 0.354, our y is 0.087. So so when we select another input, we will be using this instead of using the first initialized values of the weight of the neuron. So here my my minimum weight, minimum neuron value is 4.44. So I use the index so that I can update my weight and use it again. So we have 3.97 for 0 and 5, 3.21 for 3 and 4, 6.13 for 0 and 5, I negative 5, uh, 3.98 for 5 and 0, negative 4 and negative 3 for 5.98, to 3.70 for 4 and 3, 5.69 for negative 5 and 0. So after solving this updated uh, weight would be used to another epoch. So instead reusing the first initialized weight, we need this, or we need the new updated weight for us to solve for another epoch. But we need to change the learning rate and the max hat uh, rate radius or sigma. So here we have negative 3 and 4, which is 5.30, 5 and 2 would become 4.58, my minimum, for 4.35 for 2 and 5, 3.93 for 0 and 5, 3.21 for 3 and 4, 5.69 for 0 and negative 5, 4 for 5 and 0, 5.59 for negative 4 and negative 3, 3.45 for 4 and 3, then 5.38 for 5 and 0. Then after that, we also need to use this so that we can solve for the epoch 3. But because this would be randomized, the values would absolutely change because of inputs. So that means that if I if my first input would be 0 and 5, so my updated weight would become different. So that means that my new neuron would become different, and also my updated weight. Maybe this 5'2" would have 4.66. It would not be the minimum of this uh, set or input. So that would be all. Thank you for listening.